Hi, hello, good afternoon everyone. Thank you so much for joining us today. My name is Madelon Privé and I am a partner manager at Google Cloud for the Benelux region. I'm super excited that we have super strong partners joining us today. NextNovate, Xebia and Qodea. And let me check, plenty of a calendar, yes. And one of the sessions we would like to kick off with is NextNovate, and therefore I would love to call Stefan on stage. Thank you very much.
Thank you. I've got my own microphone. All right. All right, welcome everybody. I'm going to talk about AI applied, build versus use. And very quickly about NextNovate, you have to sit through this, sorry. So we're a Google partner. We founded in 2016, about 82,000 users that we serve with our services, about 30 plus employees, some very large and some very large customers here in the Netherlands, but also throughout Europe. Very quickly about myself as well. My name is Stefan Hogendoorn. I'm the chief geek at NextNovate. I tend to know, or at least try and explain quite a bit about what we can do with the Google Cloud, what we can do with AI and those types of things within the technology. I was founded slightly earlier than NextNovate, by the way. All right. What I'll be talking about, and that's where the build versus use story is all about, is the pitfalls of AI. If you look at an AI project, most of the time these projects get started with, oh, let's build an AI solution quickly. Usually, if you want to do it quickly, you get what you quickly set yourself up to, usually a failure. I love the one that's next. Can we get this, or can we do this with Gen AI? Because everybody heard about Gen AI. So every second question I get about AI is, oh, can we do this with Gen AI? Let's have a look at that as well. It's one of those pitfalls where you go, oh yeah, we can do that, and then all of a sudden it doesn't turn out to be that way. And last but not least, and this one I really love, especially when we're talking about large language models, customers that come up to us and say, hey, I think we need to train our own model. And they, especially them, want to train their own large language model. You have to have a slight discussion with them that, yeah, you probably don't have to. So if you look at that, and if you look at this from the point of view of, hey, we need to build everything ourselves versus, hey, what can we use that is already available? Obviously, there's quite a bit that we can use. And that's basically the premise of my whole presentation, the build versus use discussion. Now, how do you avoid some of the pitfalls that I just mentioned? Well, easy. First of all, sit through this presentation. Second, understand the AI landscape. Understand what's out there. Understand what you can use. Then decide if you need to build or if there's actually something that you can use. And I think most of the time, there's probably something out there that you can use. It might not be 100% fit, but it certainly is going to get you there. Also, make sure that you leverage the power of existing solutions, not only from a point of technology, but also from the knowledge side of things. Don't try and reinvent everything yourself. If you've been in IT for as long as I have, I've seen all the waves where people went like, oh, this is great, I have to build my own. I have to build my own framework, I have to build my own models, I have to build my own whatever. There's a lot out there. Leverage the knowledge that you have. And most importantly, make sure that you pick the right tools. If you have a large case of tools available to you, don't always pick the hammer. You might be most familiar by using a hammer, but you can't build an entire house using just a hammer. You can get quite far, but you can't get everywhere just using the hammer. And the same goes for AI, and the same goes for building your solutions that leverage AI. Make sure that you pick the right tools for the things that you want to do. Now, if we talk about understanding the AI landscape, then we have to understand that different people within the business have different requirements. Obviously, there's the business user, I'm going to separate it in three areas. So the business user, the data engineer, and the data scientist, completely different tools. For example, the business user might be very happy using something like Gemini, using Gemini within their workspace environment. Data scientists, you can probably use Gemini to help you pick the right tools and do some of the technology that you want. but you probably need more specific tools. The same goes for the people that work with the data that you would use to build your models and to train your models. Though, as a data engineer, you also need the tools that are suitable for your specific need. So that's why it's important to understand what is available in the landscape and what is your role within that landscape, and from there pick the right tools. I've seen too many times where business users try to use way too advanced tools that are really suited to for example, a data scientist, or where the data engineer starts to move into the space of the data scientist, or the data scientist starts to move into the space of the data engineer. If you start out on the wrong foot, and if you start out on the wrong side, with using the wrong technologies for the tools, or the wrong tools for the things that you're trying to achieve, you're setting yourself up for failure. So really understand where you are in the landscape and what is your specific role in it. And it might sound obvious, but next time you start a project, really look at, okay, so what is my role in the project and what tools do I need to use here? I'm not going to talk to everything on this slide, don't worry. If you look at the tools, there's different categories. You've got the no-code, low-code type of tools. You know, very useful for your business users, your people with a bit of IT skill and all that. If you're an AI engineer or a data scientist, you know, the low-code might be great. If you want to build a very rapid prototype, you know, you just want to get your feet wet, understand what the problem is. If you look at ML ops, as a business user, you shouldn't care about that. It is something that obviously is needed if you run the business, but it is not something that you should be really concerned about. If you're an AI engineer or a data scientist, then yeah, you heavily depend on what you have in the ML ops suite. So if you, for example, look at what Google has with the Vertex AI suite in terms of ML ops, there's quite a few tools there that you can actually leverage and that you should use. Again, you might be prone to say, oh, I need this specific thing, or I need to do that, and I need to build that. But look at what is available. Look at what is available in the suite. And obviously, as a data engineer, if you have to do data engineering, if you have to build your pipelines, I'm sure you've already figured out that, you know, building your entire pipeline in some Python script that you decided to build on is probably not the most efficient. It's probably not the most durable and sustainable way of building your solution. So use the tools that are available and really understand the platforms that you're working with. And I cannot emphasize this enough. I'm going to try during this presentation, so I'm going to probably repeat this so many times, but make sure again that you understand what is available. So if you look at Google Cloud Platform, understand the tools that you have in that environment to run whatever you need to do. So if you look at a build versus use dilemma, you know, developing a custom ML model using TensorFlow, PyTorch, those types of things, absolutely cool. You know, as a data scientist or as an AI engineer, it's probably something you want to do. You know, you get your, that's probably where the fun is. However, if you look back at some of the business needs, or if you look at some of the requirements that the business might have, it might not be like, hey, we build us a new model, or we want you to geek out on PyTorch or TensorFlow. It's really like, hey, build us this particular solution. So that's where we get into the use part. Also understanding what models there are. If you look at Vertex AI and the model garden that Google has there, there's so many models that you can use, so many models that you can leverage. Also, if you look at the pre-trained systems that Google has available, then you really have to come up with a particular, very good use case on why you should not use that, or use that as part of your solution. It might be that it doesn't fit your entire solution, but make sure that you at least get the components, get the building blocks. If you compare this to a Lego, you're not going to build the Lego blocks yourself. You're going to use whatever Lego blocks that you have available, or you're going to make sure that you have the proper Lego blocks to build whatever you want to build. Same goes with this. Also, in terms of use, do not, again, try and reinvent the wheel. There's a lot of knowledge out there. There's a lot of information out there. And if it's too much to compile, you know, have a look at a Notebook LM. Throw a few pages in there and ask it to make a podcast for you, and you have all the information that you need in about 11 minutes, and then you can do your deep dives. I'm paraphrasing, or I'm kidding, but there's a lot that you can use, a lot that you can learn. If we look at a bit further at the build versus use, make sure that if you have a business objective, your gut reaction might be, oh, you know what? Let's build something because it's going to be a perfect in perfect alignment to what I need. I'm going to perfectly be able to solve this one particular specific problem. But also look at the stuff that you can use, because most of the time the solution that you're building doesn't necessarily have to be 100% perfect. Already, and that's a discussion that you should have with the business, if you build something that's going to cover 80, 85, 90, 95% of the needs, you're probably already creating such a massive reduction that in cost and improving efficiency, that even if your solution isn't 100% a perfect fit, it's probably still going to make a massive impact. Of course, there's exceptions there. You know, if you're looking at life-critical systems where you have to monitor if somebody needs to go into surgery or not, then yeah, you probably want to have it 100% correct. But if it's a common business problem, then you know, most of the time 95% is okay. And I know that from an engineering point of view, you probably want to get it 100% correct, but make sure that you understand the business need for this as well. If we look at experience and resources, you know, if you use what is available, you can probably be more efficient. It's kind of in line with what I was saying earlier. It will get you to market earlier. You know, if you have to build everything yourself, if you have to really compile and start using the building blocks, you're increasing complexity in your solution. And most of the time, what you're trying to achieve anyways is complex enough. Last one, maintenance and scalability. Hopefully a lot of you have experienced that once you've built a model, you're not done. You know, you've built your model, you've built a solution, but then the solution has to go into production and it has to run. It has to run for a month, a year, 2 years, 5 years, whatever. How do you do that? And again, it's vital that when you start designing your application, when you start building your application, that you also look at the part where you look at the maintenance and the scalability of your solution. Again, looking at tools like the ML Ops features that we have in Vertex AI within the Google Cloud, there's a lot that can help you there in understanding the performance of your system, in maintaining your system, deploying new versions, seeing if your model is rusting and those types of things. Make sure that you understand it and use what is available. Don't try to build that. Leverage the experience that a company like Google has in running these models at scale, and try and use that in your own solution. It'll make your life a lot easier, or at least the engineers that come after you and that have to maintain the system. Okay. Again, if you have to leverage the power of existing solutions, look at business value, development effort, and production. What is it that you're trying to achieve? This is okay. So do I need to have that 100%, or can I do 95%? If I use stuff that's out there, can I actually lower the barrier to get this company to use an AI solution? Because the AI solution is probably going to help them move forward. If I set the barrier real high, like, oh yeah, I have to spend months and months and months training a model, building a solution, versus, oh, you know what, I can do this in a month and a half. Then you know you're probably going to lower the entry barrier for organizations to get onto the AI bandwagon and really start leveraging this. So understand that. But again, also, if you look at your running this application in production, if you build that thing off the cuff and just do a quick development, you might create a problem later on where it was quick in development, but it's going to be very timely, or it's going to be very costly in maintaining and running the system. So if you look at the environment, if you look at the tooling that you have available, make sure that you look at the simplified maintenance and scalability, look at reducing the time and effort, not only to develop the solution, but also to maintain the solution. Right. If we look at what is available in existing solutions, again, I already spoke about some of the Google offerings. I think the most important one in the entire stack, or what is encompassing the entire stack within Google, is Vertex AI. Vertex AI has a few very important models pre-built with AutoML. They're great kickstarters. They're great kickstarters to start your project. You can daisy chain them. Everything is an API. So as a developer, even if you're not an AI developer by training, You know, if you're able to write software, or if you're able to do a bit of coding, using these pre-built models, those AutoML models, really help you to kickstart your project. They're great. You can include them in stuff like BigQuery, so that you don't have to build everything from scratch, but they're pre-built and pre-trained. Same goes with the ML APIs. You know, why bother creating your own model or to do image recognition, or to do speech-related things, or sentiment analysis on text? It's out there. There's an API for that. Again, understand the ecosystem that you're working with. Understand the value that that ecosystem has. Once you start looking into more complex systems and structures, definitely look at what Google has available in their model garden. There's so much there. There's obviously there's all the Google stuff there, but there's also stuff from that is open source and that you could very easily incorporate into your own project as well. So you don't have to do everything. Well, of course you should do everything on Gemini, but if you don't want to, if you have a very good reason, there's other open source solutions in there as well that Google is also offering you as a developer in an out-of-the-box solution. All right, I'm getting to my point. So, and the point was pick the right tool. Did I mention it before? Make sure that once you start, before you start your project, understand what is the business value that you need to create. Understand if the requirements that the business have, is it really that unique that you really have to build something yourself, or is it something that you can leverage, or are there components in your entire solution that you can leverage? And then if you start building the solution, make sure that you pick the right tools. Also, make sure that you pick the right people in your team. I'm not saying that the people in your team are tools. There's a joke in there. But make sure that you pick the right people. Make sure that you pick the right skills. If you need to do a lot of data preparation, it's great if you have a bunch of data scientists, but you probably need a data engineer as well. If you have to do a lot of API integrations, yeah, it might actually make sense to have a regular developer in there as well that can help you build the solution that you need. And also look at the way that your application needs to be deployed and needs to be run after you've created it. Because creating is one thing, running it is something else, and running it in a sustainable manner is something completely different and really requires you to give it a lot of thought before you start your project. If you start thinking about, oh, how do I run it once your code is complete, you're a bit too late. Also remember, the not invented here thing is not so bad. As I mentioned before, I've been in IT for many years. I know that especially software developers hate to use stuff that was developed by somebody else. In this particular case, you know, there's a lot out there that you can use, and there's a lot of knowledge and a lot of skill that you can use. So definitely start using that. And if you don't want to use what somebody else did, you know, at least use some of the AI tools out there to at least understand what they did and how they did it. So if you have to redo it yourself, you're not stepping into the pitfalls that they stepped into. Okay. So to wrap this up, what is it you need in your project? Look at the skills, the time, and the tools. Tools. What are the business expectations? The business might have very big expectations of what you're doing, but don't be afraid to push back and set and manage the expectations of what you can actually achieve. And also tell them, like, hey, if you want to have this 100%, this project is going to take you a year. If you're happy with 95%, I can do it in a month and a half. Yes, I know the 100% doing this for a year, building it from scratch as an engineer. From a business point of view, yeah, probably not. Okay, what are the tools that are available, and are there already solutions I can use? Did I mention Vertex AI before? It really is. If you haven't looked at it before, if you don't have the experience with it, have a look at it. It's such a massive set of tools that you can use, and if you really want to go through it and understand everything, all the components that it has, you'll spend quite a bit of time reading through it. Use your favorite tools. I use Notebook LM to compile all sorts of information from Vertex. From the Vertex AI website, and I can literally ask it any question that I need to help me build my solutions and to help me select the tools that I need. So definitely have a look at that as well. Thank you for your attendance and thank you for your attention. And if there's any questions, you can find me later. And I'm now going to hand it over to Mike.
Both. Is that working? Hi, can everyone hear me now okay? Excellent. So a mic malfunction in two ways there, so apologies for that. Can I invite the people at the back? If you'd like a seat, there's plenty of room at the front. Come down and help yourself. Again, as I said, I don't bite, so yeah, please feel free to grab a seat. So thanks ever so much for coming along this afternoon. My name is Mike Smith. I'm the Director of Engineering and Security at Qodea. So I wouldn't be offended if you've never really heard of Qodea before. It's the largest European Google-only partner, but it is the culmination of two previous partners, so AppsBroker and CTS, who you may be more familiar. So the birth of Qodea has been less than a month, so again, have a quick look on the website. Any questions, I will be at the back after this session, so come and find me if you like. So when I was asked to present here today, it was interesting. I thought, well, I have lots of people who are into AI. Security is often perceived as a blocker, not just in AI, but multiple scenarios within an enterprise. Security are blocking. I've made almost a career out of being the tonic to that term, security as a blocker. And it's really about how we can be proactive and address that. Because really what I'm looking to do is to make sure that we can make the reality and the promise that AI presents for organizations a reality by making sure security is an accelerator and not a blocker in that scenario. So hopefully today I'm going to share some insights from a CISO perspective. So I was previously a CISO at AppsBroker. I've spoken to lots of CISOs over the last few years, so I've got a good insight as to what their concerns are and really what their internal thinking is about AI. There we go. So what is the challenge? Now this is the challenge from a security perspective, because what I want to share today is how do you broker a conversation with your security departments to make sure you're not going to get the blocker at the end. Everyone says security shift left. It's an overused term. When I use that, it's about having the conversation. It's about getting your security architects, talking to your data scientists, and being open and transparent about what you're trying to do. And the reason for that is well-founded. Security generally struggle whenever we get a technology paradigm shift. And there's lots of evidence of this over the recent history. Here are some examples. So, for example, software-defined networking. When it was first released and first invented, if you like, and first brokered, security, first question, well, where's the perimeter? Where's my DMZ? What does it look like? We really, really are quite bad at dealing with change, which is shockingly terrible, bearing in mind we are in technology. It's a changing, evolving landscape. And even more pertinent is security is forever evolving. Think of zero-day vulnerabilities. Our landscape is forever changing. So security should really be the ambassadors of change, but that's definitely not the case. So with SDN, it was really, well, distributed firewalls, awesome. I love lots of firewalls, but my very next thought is how does that fit into my firewall change process? I only have 2 windows a week. How is that going to work? So it's really about changing and maturing security's interpretation of how we're going to operate going forwards. Next is the cloud. And again, we're all sat here, the cloud is a fantastic domain with which to provide solutions. And again, very well optimized for AI. Security for the cloud, with a security perspective, was a huge blocker. And the reason why is because, and I'll put my hand up, I've been guilty of coming out with this term myself. I don't care where it's going. I want the same guardrails, the same controls. I want it to be Palo Alto. I'm not changing my processes and technology because I've invested lots of cycles in understanding it. And it's embarrassing now I look back because now I'm the complete reverse. Now, let's leverage the cloud. Let's use the cloud to secure the cloud. Let's make sure that, and again, there's lots of awesome examples of this with many tools that are now kind of cloud native in their adoption. Another one, SIEM. My SIEM can't cope. Again, it's about not being bound to the tool. It's about actually looking at your requirements. What is your requirement? Well, we're going to be in the cloud. Our requirements for logging and the whole monitoring is now going to change. If we don't change that requirement, then more likely than not, things are going to fall over with the sheer volume of logs and events that are coming through. Containerization, another great example. So these are all massive wins in technology, but are huge challenges for security, just because we needed to try and change that mindset as we went through. And finally, AI. So what I'm going to present today is how do we make sure we have lessons learned? What have we learned from those previous paradigm shifts to make sure we can be an enabler from an AI perspective? AI. So this is the topic for discussion. Quick show of hands. I'm not sure if you can see the link on the bottom. 6 Thinking Hats, Edward de Bono. Has anyone read that or seen it or even used it? Quick show of hands. Excellent. There's at least 2 people in the room that have seen it and know what I'm talking about. So I'll just give you a quick illustration. So this is about varying personas. Here we've got 2 hats. We've got the yellow hat. So the yellow hat is the optimist. He's going to be there, he's looking at the possibilities, the upside. He really is kind of the product owner. He's the person that tries to evangelize the business. You've got the white hat, far more information driven. So it's be your data scientist, your data engineer type person. But really it's about having or considering differing personas. Because the key here is, as I said, it's about discussions, it's about collaboration, it's about raising the points of concern and the risks to the organization and having an open forum. The black hat. No prizes there. The black hat is the pessimist. It's the person who looks at the risk. It's, can I afford not to do this? I need a reason. Well, I don't need a reason not to do it. Can you prove to me I have to do it? So a real pessimistic. You won't be surprised. That's normally the CISO. But again, it's because they're risk adverse. So all 3 of these personas are completely valid in their own opinions and their own perception of what the ask is. The key here, and this is what Edward de Bono does really well, is we could be sat around a table and we will actually swap hats. It's about understanding the other persona's perception of the problem statement. It's understanding their approaches, and then we can actually agree the way forward. And that's the key, is that once you have a better understanding of his perception of what the problems are, you can broker your engagement, you can expedite your delivery by making sure you tailor what you're saying to address those. So let's have a quick look at some of the CISO's observations. I'm assuming everyone's more comfortable with the product owner and data scientist perceptions of AI. So we're going to focus on the CISO and really kind of almost give you a cheat sheet as to how you can coerce them into a nice, rapid delivery. So first of all, the board have announced new AI initiatives. I wonder how we're going to be securing those. Often, security aren't normally engaged within a transformation. Often they actually get it subsequently. They get the announcement, we are doing this is going to be a fantastic business initiative. Oh, and by the way, I'm sure it's secure. All right, so it's all about brokering those conversations up front. So these are just some of the concerns. So what type of data are we using and where does it reside? Where's the training data? Is it prod data? Is it non-prod? Does it reside in a non-prod environment? So all of these things are going to be playing in the back of the CISO's mind, because unless he has visibility of those conversations up front, so having the security architects in play for those conversations, he's not going to have an opinion. The worst day in a CISO's life is when he strolls into work or gets called out in the middle of the night And what happens is they find out they're in a particular domain or using a particular technology he had no visibility of at all. Because if you have no visibility, it's nigh on impossible to have an opinion about the security posture of what's going on there. So it's really about visibility. Am I exposed from a GDPR perspective? Everyone knows about data, everyone knows about GDPR. 4% or 20 million euros, whichever's going to be the greater. And again, this happens all the time. When we look at AI, our attack surface can absolutely expand and explode with regards to the visibility and access of that data. So we need to ensure we're actually all over this. So when he's asking noddy questions about the data classification, he's trying to construct the risk profile that he needs to address for that solution to be correct. How do I reduce risk? It's the narrative that all business speaks. It helps the CISO. So if you can actually have that or help educate on that risk conversation, it will really assist. And how can we leverage AI? So security is not a silo. And contrary to common belief, security is not a proliferation of silos. For effective security, we should be breaking down silos. And what I mean by that is security is a holistic oversight of end-to-end operations and solutions. So we need to make sure we're removing those silos to have that open and transparent conversations. So what this is all building up to and why we have this kind of 6 thinking hats, open, honest collaboration is about trust. It's about trust between your security business unit or your SISE or your security environments and departments and your business units. How do we build trust? We build trust by having open and honest conversations. We build trust by the security organization knowing that the business units aren't going to be promoting shadow IT, they aren't going to be promoting shadow AI or running off and building things in isolation. It's all really about having that open conversation, because once we have that transparency, then we can actually be far freer in what we're actually doing with our enterprise data. But it all revolves around trust. And that's a two-way thing. How we try and do this from a security perspective, security at scale is always a challenge, because everyone knows there's a massive cybersecurity resourcing problem. How do we fix that? Well, we leverage other people in the organization. So we have security champions. So what we do is we embed security champions within every development squad. So what we now do is it's a cross-pollination of skills. Because one of the CISO's concerns will be, I don't have any AI expertise in security. How do I fix that? Well, how I fix it is I leverage my data practice and try and do that cross-pollination. And it needs to be relative to what the job roles are. So here what we'll be doing is we'll be promoting AI within security operations. So again, from a Google perspective, you've got the SecOps suite, which was obviously based on Chronicle and Simplify, and now Mandiant. It's got AI and native language inputs to that, which mean that we've got far more effective SecOps operations. Because when you look at an operational center from a security perspective, it's got so many vendors, there are so many various CLIs, there are so many varieties of vendor within that security ecosystem, that if you're a security operations engineer, you need to be a guru in all of them, which isn't obviously possible. So AI can be leveraged to make security far more effective, and from an operational perspective, it really does promote that efficiency. So it's all about trust, which we're going to come back to. So how can we help? I'll just build this one out. Users, click. Boom. Here's the bigger picture. So when I've secured, so obviously, so AppsBroker have been in Google Cloud for 15 years. We've done we've got a massive data practice. And what's really quite cool is that if I ever had a data problem, I just ring my head of data and say, Matt, what was the issue? I need some architects to have a chat, an opinion. Can you tell me what you're doing in this space? So I had access to loads of data professionals. When I look at data, when I look at ML pipelines and how we secure them, we can almost chunk it up. This is how I used to do it. Chunk it into 3 blocks. We can chunk it up into the data ingestion part. So what's actually occurring? Where are we getting the data from? What's the data classification? Is it public? Is it classified? Is it highly confidential? How is it actually labeled? Because that label will then determine the appropriate security guardrails that we need to apply. Because being effective in security is about applying the effective guardrails. It's not about being the most secure on the planet. It's about appropriate and effective security. And that's key and will be determined by your data classification. Tagging taxonomies. Once you've got your classification sorted, if we then have a tagging taxonomy which says this is how I implement policy based on the data classification, that's a fantastic mechanism to be able to leverage, particularly in cloud. What's really quite funny is when I actually have these conversations, have you got a tagging taxonomy? The answers are resounding, yes, we do. We've got 4 of them. That's less useful. Again, we need that unified approach so we can try and implement policy as code from a security perspective. Because again, we really want to reduce complexity, promote that simple 101 engineering where we want to maximize reuse. Data encryption, at rest, in transit, all the kind of normal stuff. Last one I call out from the data ingestion is threat modeling. So threat modeling is an AppSec kind of discipline. Quick show of hands, anyone used threat modeling in the past? Or anyone, even more impressively, used threat modeling for their own AI solutions? Just the one? Cool. That needs to be more. Threat modeling is a fantastic methodology. It's an AppSec discipline, but what it actually does is it actually builds out your data flow. And what it does is it's really quite clever, is it will look at the data flows, it then looks at the attack vectors for that solution from multiple personas. Whether these are external malicious actors, whether these are disgruntled internal employees, it will apply those lenses. What this will provide you is a real-time feedback for where your attack surface is exposed. And that's absolutely key to making sure our AI solutions are secure going forward. And it's an ongoing exercise. So again, the reason for this is that, as I mentioned, we don't live in a static world. So when we've deployed it, we've done our audits, we've done our pen test, I've got a big green tick, I'm secure, on a Friday evening, I can have a horrendous weekend, Log4j has just been announced, I'm significantly less than secure on a Monday morning. So it means all of these kind of practices are ongoing efforts to improve security. The middle block are AI-enabled systems. What are we looking at there? So we've got our training data, we've got our training algorithms, and we've got our trained model. But again, how do we actually ingest it? We're moving into our training data. We've got some threats in here, and obviously classic ones, so data poisoning, adversarial attacks, so generically, model theft, model inversion. These are all well-known entities, but what's really quite interesting is that we're proactive about how we address these, and you actually illustrate for your security teams how you're addressing those proactively. It's a much easier conversation, because when they're throwing these out, you're saying, well, what about data poisoning? You can actually, well, this is how we're working it, this is how we're authenticating, this is how we're authorizing access to this data, this is how it's encrypted. So being proactive about those conversations and having an understanding of those guardrails is absolutely key. Security champions, I've already mentioned, cross-functional teams. When we're looking at squads, you want to have a squad with a data scientist, with an app web front-end dev, with a security guy in there as well if at all possible. The more you can promote cross-functional teams, again, the better the communication, collaboration, and the more secure that eventual solution. Over onto the right-hand side. Now, the interesting thing here is that this is really kind of how we interface. So the AI outputs are really going to be, well, what's the app look like? What are we using? How is the user interface for that? So this is really application security. So we need to make sure we're embedding the OWASP top 10 into those. So valid inputs, make sure that we're validating that kind of how it can be done, what the guardrails are. But also remember, we've got our AI inputs in there as well, because these things are now feeding back. So we need to make sure the active guardrails are in place. Now, all of these sound very, very AI specific, and some of them are. But what's really important about this slide is that you need to build it somewhere. And depending on the location and how you build, will also determine how secure you're going to be. So we can actually leverage infrastructure guardrails. So if we're looking at secure foundations, so let's take Google Cloud, for example. We're looking at our secure foundations, we build it out, we embed the guardrails, we make sure that from a security perspective, you're building on a secure foundation. You then move up through the stack and you create an opinionated landing zone, because you know your target state is going to be an AI app. So you become more opinionated as you move through, gives you a security in-depth approach, but it also means you don't have to worry about all of the security risks. You're leveraging controls from lower levels. And that's how we promote that security in depth and security in design. AI-enhanced operations. Every CISO has a challenge with resourcing. If you can illustrate how you can remove that challenge, how you can promote security operations and do security at scale. So again, as I mentioned, Chronicle's a fantastic example of this. Also, Security Command Center. So Security Command Center Enterprise now has this AI embedded into it. So we can have natural language infusion of the queries. So the SecOps guy doesn't have to understand every CLI and every language he's looking to interrogate. He's simply using natural language, which means your pool of resources is now far, far larger. So again, bear that in mind, because if you're fixing one of your CISO's problems just simply by promoting it and actually helping him understand the benefits, it's a much easier conversation to have. So in conclusion, always be proactive with security. Engage them. Don't wait for them to come to you. Actually go to them. Because it does pay dividends, not only from a time, delivery, and kind of realizing business requirements, it really does mean that you will have that open and honest conversation. That means it will be easier for you to accelerate your AI journey going forward. OWASP, fantastic resources. Please do go and have a look at these. You've got your LLM OWASP Top 10. So again, it's tailored, it's open source, and they're doing it with a lens for promoting AI. So absolutely fantastic resources. MITRE have now got a subset and community specifically for AI. It's called MITRE Atlas. Really, really compelling. MITRE is threat-based design from an architecture perspective. And again, if you go into a security conversation and you say, oh, we've looked at MITRE Atlas, I'm really interested in X, Y, and Z, you'll be on a much better footing. And you've got your generic kind of regulations and assistance, depending on where you sit geographically. So, that was a security interlude. So thanks for your patience. As I said, I will be at the back for questions later on if you want to come and see me. Before I hand over to my colleagues in Xebia.
Test. Okay. Everyone can hear us. Nice, the mic is working. So building conversational agents with Google Cloud. We see conversational agents being at the forefront of the Gen AI revolution. So during this part of the workshop, we would like to take a deep dive in how you can leverage conversational agents to bring value to your company using Google Cloud. So we are Jetze Schuurmans and Sander van Donkelaar. We are both machine learning engineers at Xebia Data. At Xebia Data, we help our partners ideate about Gen AI use cases, develop them, and also scale them in production. And during this workshop, we would like to show how we did that for conversational agents using Google Cloud for a large international bank. So if we take a step back, we see a parallel between the internet revolution and the Gen AI revolution in the sense that there's enormous potential, however, for systematic impact. However, it also comes with some challenges. Nonetheless, we see a large potential for a lot of business value being created, and one of these use cases is conversational agents. So what are conversational agents? Conversational agents are like virtual contact center agents, so they can help with concurrent conversations with your end users, and they can perform specific actions that you define. For example, the use cases for conversational agents are ranging from customer support to automation and to employee assistance. And there's basically two types of conversational agents. We would categorize them as rule-based agents on one hand and generative agents on the other hand. And rule-based agents have been part of the industry for quite a while now, and newly emerging are these generative agents. And both of these type of agents have different benefits, but also different limitations. For example, the rule-based agents are often too simple for complex use cases that companies have, while generative agents provide more flexibility and therefore a larger potential to handle more cases. But there are still some common challenges when implementing these conversational agents in production. So Sander.
Yeah, So, what are some of these common challenges? We've been working with a wide variety of clients into bringing Gen AI into production for over a year now, and we've been working at different phases of this Gen AI lifecycle. The thing that we are seeing is that, in general, building LLM or Gen AI applications, chatbots, is not easy because of the so many heavily intertwined components that you need to manage. And this on the slide is an example. It's a bit of per illustration. I did not even list anything I could think of on it, right? The thing of it, if you can go to the next slide, or maybe, as a result, most companies are actually not getting the benefits of generative AI that are promised. So then the question becomes, how can Google Cloud help? I think one of the nice things that Google Cloud is offering at this point in time is their customer engagement suite, which is a fully managed, unified platform for building AI-powered contact centers operations. With conversational agents being the core of this specific platform, but at the same time provide a wide variety of capabilities to connect it to other third-party systems and integrate it in your wider organization. What I really like about this is we are already seeing tangible value at our customers. We are using this specific platform to create virtual assistants that can provide instant answers to questions related to daily banking. And what we are seeing are two big benefits, but together can really accelerate generative AI inside your organization. At one hand, we see a shorter time to market, where generative AI, compared to traditional chatbot development, is much simpler to do. This is very nice because it means that you can focus on creating value earlier. You can pivot from your POC to production quicker. But we don't have to sacrifice performance. What we also are seeing at ING is that this conversational agent is providing improved deflection rates and higher levels of customer satisfaction consistently. This means that less calls have to end up at human call center agents on average, which is of great benefit.
So what are the different components of a conversational agent in Google? As a start, we have the conversational agent itself, which starts with creating prompts, which are basically the instructions for the conversational agent. Then we can provide examples that can illustrate what desired outcomes might look like. And then we have flows and pages, and these are one of the core components of the agent that leverage us or provide us the leverage of combining the generative approach as well as the traditional approach in rule-based agents. And for these generators, this is where the Gen AI comes in. So this is where we can integrate with tools like Gemini and really make the agent more flexible in the type of conversations that it can handle. But now we want to make the agent specific for your company. And we can do that using data stores. So using the data stores, we import the data that you select and provide that as context to the agent to help with specific questions. And then finally, this whole solution integrates nicely with your current existing cloud and data infrastructure. And using tools like webhooks, we can also integrate with other enterprise systems that you are already using. So let's take a deep dive into the different components.
Yes, building your conversational agent. As Jetze told, you can generally define agents into two categories, right? Generative and rule-based, both having their drawbacks and benefits. I think where conversational agents in Google really are shining is that it takes a hybrid approach and combines best of both worlds. We start out with flows. These flows, they consist of conversational paths or journey. You can think of it as a type of scenario that your customer can encounter while chatting to a chatbot. Each flow consists of pages. A page represents a step in that flow. On a page, you can provide an action. You can either give a response, you can call a webhook, you can call a generator, you can maybe do all kinds of operations over there. You can see by the arrows that you need to route between these specific pages. This is called routing. Routing can be done by detecting intents. Detecting intents is like using more traditional machine learning to capture the intent of an incoming question. We can use LLMs to route the query towards the appropriate flow of page, using this time a more dynamic approach. At the same time, our responses can either be fixed or AI generated. You might think you always want an AI generated response, but it's really not the case, right? If a guardrail is triggered, for example, you actually don't want your LLM to say anything because it could potentially be harmful for your company. As Jetze told earlier, we can use generators for generative AI. We can combine Gemini with custom prompt to generate responses at runtime. At the same time, we can use these generators for all kinds of other things. Like I said earlier, we can do it to route it, but we can also do it for response generation, data extraction, and we extract structured outputs from our conversationals and send this back to our other enterprise systems, but also for security. We can use generators as guardrails to scan incoming and outgoing queries for unwanted content. And then a third part here is data stores. With data stores, we can generate responses on our own data. Data stores are an end-to-end solution to automatically both index and retrieve data. For those in the audience that already are more technically known with LLM concepts, you can think of it as the critical step in retrieval augmented generation. As you might know, when you build retrieval augmented generation pipelines, it can be quite challenging. Of course, you can do it. There are a lot of examples on the internet. But to do it well is still that you need a lot of components to take care of. You need to do document parsing, document chunking, embedding generation. You need to store it in a vector database. You need to maintain this vector database. Then when you retrieve the documents, you can do things like rewriting, summarization, rounding, whatsoever. There are a lot of things that you need to do. And the nice thing here is that data stores handle this for you on a very nice way, while at the same time providing you the flexibility to do these things if you wanted to. Moreover, data stores can be connected to a wide variety of different data sources. You can connect it to your data in BigQuery, cloud storage, but you can even let it index your public website. You can literally build on the technology that Google has been providing for years in their traditional search engine, where it has been indexing websites for ages. I think also what is nice, and what I didn't mention just yet, is that this conversational agent builder is low code, right? It's console first. This means that the user interface enables non-technical users to also develop prompts. What I'm seeing at ING is that this is really powerful, actually. I'm an engineer myself, and when I hear low-code solutions, I'm always a bit cautious. But what we see there is that we can actually directly leverage the expertise of domain experts to contribute to our system, which I think really also benefits the eventual quality. And as I said earlier, it's a Google Cloud product. It's really easy to integrate it with existing cloud and data infrastructure. There's an extensive support of data sources for your data stores. It's really easy to export conversations back into your platform, either to BigQuery and cloud logging, and where you can do all kinds of things with it. For example, you can create alerts when guardrails are triggered, or you can integrate it with third-party observability solutions. At the same time, we can leverage webhooks to let our agent call APIs such that it can perform specific back actions if required. Now, I think this is really nice because it also allows us to create this strong feedback loop, right? What you want to do when you're building LLM applications is that you want to constantly monitor its output and use it to steer the development of your chatbot. Now, this is what we can actually do with these conversational agents. We can collect feedback and log conversational interactions to enable advanced analytics and monitoring, at the same time also connected to our downstream services with, very easily. And then at last, I already said this before, I really like this approach where we can leverage both low-code and code-first tooling or approach. Non-technical users can use the console to develop conversational agents, But at the same time, more technical users, like me and Jetze, can leverage the client SDKs or use infrastructure as code tooling such as Terraform to provision and build and deploy these agents.
Yeah, like Sander mentioned, as an engineer, when you mention a low-code solution to us, we're always a little bit afraid that it comes at the cost of engineering best practices. But what we see with the conversational agent services of Google is that it doesn't come at the cost, but it actually helps us enforce these best practices in the platform and in the tools that we build. For example, Google enables us to use infrastructure as code, where every component can be provisioned using tools like, for example, Terraform. We can build CI/CD pipelines using the client SDKs of Google and REST APIs to fully automate the deployment process and also make sure that it's staging across the different platforms. And lastly, we have version control enabled in the bot, which means that agents in Google are fully integrated with GitHub. And if you are not using GitHub but another code versioning tool, the agents can still be exported into human readable file format, so we can actually do change management very rigorously. And to conclude, we can unlock the value of Gen AI using conversational agents on Google Cloud by leveraging these three benefits. First, it's basically a best of both worlds in the sense that it combines precise conversational control as well as the generative features that we would like to leverage from Gen AI. Secondly, it's a low-code solution, which means that we're also enabling our domain expertise to leverage their knowledge and help us improve the bot directly, without coming at the cost of the technical rigorously that we like to see as engineers. And thirdly, it's cloud native, which means that it nicely integrates with your existing cloud infrastructure. And as a result, the benefits are that you have a very short time to value, as we've seen in the case at ING, and a low cost of ownership. So thank you very much for your attention. If there are any questions, we would be happy to answer them. And don't forget to drop by at the Google booth and the exhibition. Thank you very much.